Hello and welcome again. My name is Panchaleshwar Naik and this is my video training series for Portworx. So this is my first recording on Portworx, and today I'm going to talk about Portworx basics. So I will not go very deep today, but I'll just have an introduction session to Portworx and I'll show some demo too. And today I'm going to talk about what is Portworx and why Portworx is needed. Then we'll discuss about how it works, how the Portworx works, and we'll have a small demo too. So let's move ahead. So you see here what is Portworx, and we have defined as universe. It is a universal Kubernetes storage orchestration platform. So in short, Portworx is a software-defined storage overlay for Kubernetes, and I assume you already know Kubernetes. So I assume that you already know what is a Kubernetes cluster, how it works, what is a control node, what is a worker node, and how the cluster works. So with that assumptions, and I know why I assume that you already know what Kubernetes is used for. Just to repeat, Kubernetes is a container orchestration platform for stateless applications. It was initially developed by Google for running stateless applications as containers. But today, enterprises run stateful applications on Kubernetes too. So, Portworx is a storage orchestration platform for Kubernetes, and that's what it's all about. Well, just to show you in this picture, we see that there are some stateless I'll use my mouse. So there are some stateful applications we want to run on Kubernetes environment. So I assume that you already know this layer. So this Kubernetes, I assume that there are nodes and there are worker nodes. And on those worker nodes, these are some of the stateful applications we want to run. And when we want to run this stateful application, they need some storage. So when it comes to persistence of data, we definitely need some storage attached to those containers. And here in terms of when we talk about Kubernetes, it is all about pods. So containers are packaged inside pod, right? So whenever we are running a stateful application inside a pod, each pod is again associated with a storage. So it can be if you see here, this can be attached to any cloud storage, like on AWS EBS volumes, or you can have a local attached storage, direct attached storage too, and we can have some storage arrays and from different vendors. Here it is FlashArray from Pure Storage, FlashBlade from Pure Storage, and we can have AWS S3 as well. So as a storage for saving the files and so on and so forth, files and objects. So with that, I would say that Portworx manages all the underlying storage as Kubernetes manages the applications. So I'll talk more about it in my following slides, but for this slide, I would say that if Kubernetes is the orchestration platform for applications, stateless applications, Portworx is the orchestration platform for the storage volumes or for volumes for the stateful applications. So with that, we'll move forward. So here, why Portworx is actually needed. So what problem it solves. So I'll give three answers to it. So this is the first answer. So why do we run storage? Why do we need a storage overlay, right? So in this picture here, if you see that if we want to run a pod or multiple pods in a particular node, so this is where this orange color one, if you see that this is a node, one node, and suppose I want to run multiple pods here, and these are the stateful applications, and then each stateful application pod needs to be attached to another, it can be a volume, physical volume, or LUN, or a direct storage. They need to be attached because it needs to persist. The data persistence is required. So there is a one-to-one map to each pod and volume. So here, if we have hundreds of pods, if we are running in a particular node, which is quite possibly in a microservices environment, we can have smaller number of smaller databases, which are all huge in number. And then what we need is, we need also hundreds of volumes to be attached, hundreds of volumes to be attached to each node. So that's the reason actually, which is sometimes not possible, or it can be sometimes very costly too, if it is possible. So I'll tell you some examples. So you know EC2 instances on AWS, right? So if you know, to a particular EC2 instance, you cannot attach if it is a normal Linux node, you cannot attach more than 40 EBS volumes. And that's the limitations. And we can find some limitations. In fact, if you go to Google and search limitations of EC2 for EBS volumes, so here you'll find that there are limits, right? So you see here, Linux specific volume limits. Attaching more than 40 volumes can cause boot failures, right? And here, if you see some Nitro system volume limits, you see here we cannot attach instance support maximum of 3 EBS volumes is particular, and so on and so forth. There are limits given here. So that means if we want to run more number of databases or stateful applications on a particular instance, we cannot run the number of databases or stateful applications we want. So in that scenario, what we need to do? Then obviously we need to virtualize the underlying storage or virtualize the EBS volume, so that I virtualize the underlying EBS volume using something like Portworx, and I present the PVCs it is in Kubernetes object, persistent volume claims. So I'll fetch the persistent volume claims from that virtualized storage rather than direct EBS volumes. So that is one need and of virtualizing the storage. The second need is availability. So you see here, availability is a very important topic in terms of if you are running a production workload in a Kubernetes cluster. And obviously, if we are running any particular pod or stateful pod or stateful application or stateful database, then availability is much more important also. Why? Because we don't want to lose data, or we don't want applications to have a downtime if one node goes down. You see here, if a volume attached to a pod, which is running the application, this is a stateful application in node 1, and if due to any reason either this volume corrupted application goes down, then what happens? We have a data loss, because if this application goes down, data has a gravity. That means it just cannot move. If it is a stateless application, then immediately we can restart it here, and that's what it is. In fact, it's used the containers. We can restart it very fast. But if it is a stateful application and attached to a particular storage, then even if we start the application in this node 2, but can this volume be attached to these applications immediately? This is a separate physical node, or maybe a physical volume. It is a node, or it can be a VM. So this VM, this volume cannot be attached immediately. So that's the reason it is another uh, important requirement that we have a storage which is attached to all the nodes, and at any instant of time, so that wherever this pod goes or wherever it runs, it sees the same volume, or PVCs rather, in Kubernetes term. So it sees the same persistent volume claims. So that's exactly, I wrote here, immediate problem you're going to have is availability. You want volumes to be available on any node in our cluster. Whether you are running in the cloud or on-prem, you have probably a different data center. So you want to have these volumes to be available wherever the container goes, right? So that's another instance where we need the storage to be virtualized for the Kubernetes. My third point for why Portworx is application awareness. So what is application awareness? So let's take an example of an stateful applications. Let's take Cassandra as an example. So if you have implemented Cassandra in a VM, you must have done at least with 3 VMs. So that means if we want to deploy Cassandra on Kubernetes, minimum of 3 pods we need to be running on maybe 3 different nodes. So when we are deploying, when we are attaching a particular storage or volume to a particular pod, then we not only have to apply to one pod, but to the 3 pods in different nodes, right? So there, the whole application is considered as all the 3 pods rather than one pod. So when it comes to applying the life cycle of the volumes for one application, then it needs to take consideration into the cluster. So that means there are 3 pods in the application and the 3 different volumes attached. So without Portworx, then Kubernetes is not aware of the application. It just knows how to just attach a volume to each pod, but it is not managed. The volume lifecycle management is not done automatically. But if Portworx is installed, then Portworx knows that there is application running, and it is a cluster, and it has got 3 pods, and there are volumes attached to these 3 pods, and that is completely managed. That volume lifecycle management is done by Portworx. So it is just an example, Cassandra, but any application, any stateful application, if we are running, then the Portworx knows how to manage the application with the underlying PVCs or persistent volume claims. That is what is application awareness. I'll go to my next slide. So, and how it works. I'll speak a little bit here how it works. So when we install Portworx in a Kubernetes environment, so what we do is actually we install a Portworx agent on each node. So, and that when we create an agent in each node, they form a Portworx cluster, storage cluster. So what this agent does is it virtualizes the physical storage which is attached to that particular node. So, and once the Portworx is installed on the Kubernetes cluster, and whenever a stateful application asks for a persistent volume claim, the first insert its PVC. The PVC is given by Portworx rather than directly given by the volume like EBS volume or underlying any other storage by some storage vendors. They provide their storage LANs and so on and so forth, right? So the virtual volumes then bound to particular pod, and that's how it works. So It's nothing but the agent virtualize the underlying storage. So we'll have a demo and I'll show how simple it is to install Portworx on any CNCF compliant Kubernetes cluster. So we can install any CNCF compliant Kubernetes cluster. So it doesn't matter what it is, where it is, and which cloud it is, or which environment it is, which hardware it is running, whether it is a bare metal or on a VM, or it is on cloud, it is on premise, or you have your vanilla self-made Kubernetes cluster, or it is EKS, AKS, GKE, Rancher, OpenShift, and whatnot. So as long as it's CNCF compliant, we can install Portworx on it. And it is pretty simple, and it is a two-step process just to install Portworx. First we do is we install it through the Kubernetes operator. And so what we do is first install the operator, and second is we generate a Portworx specification using a generator which is available from portworx.com. It is central.portworx.com. If you go there, we can easily generate a specification with your need, and you just download that specification and deploy using kubectl command. So it is just two commands straightforward. I'll show the demo, and I'm sure you'll enjoy it, and you learn how to easily install Portworx. Thank you for watching, and we'll see again on the demo. Thank you.